This is your navigation guide to the My Big Campus physics course at Waynesville High School. The Waynesville High School physics course is organized on My Big Campus around 11 power standards detailed in the physics curriculum. Get started by logging into My Big Campus and selecting the Waynesville High School physics course. You may request to join if you are not already a member. This is how the course works. The curriculum is mapped through My Big Campus into blocks that correspond to lesson plans that address a specific power standard. Each power standard has key skills to master, essential questions to address, lessons and activities, and an evaluation plan. In other words, you'll find out what students should know for the power standard and how we as teachers will evaluate mastery of that objective. There are two ways to use this course on My Big Campus. It's designed to permit distance learning, where a student works independently on My Big Campus and does everything remotely. Our option and focus, however, will be an integrated learning environment. That's where we have distance course material used as a course outline with a teacher in the class to present, teach, guide, and coach in sync with the material on My Big Campus. The home page for the physics course shows the power standards that we have in our curriculum. Students will develop mastery in kinematics in standards 1 through 7 and will get exposure to other areas of physics in standards 8 through 11. When you select the Pages link, you'll see that each of the first 11 pages for the site address a power standard. Each block of instruction is designed to help a student develop mastery of that power standard. The first 7 blocks must be completed in sequence. Blocks 8 through 11 could be completed at any time or in any order. To complete a block of instruction, you would click on the page for that block. For example, let's say we selected Block 2, Motion in One Direction. On the entry page for the block, it starts by listing the key skills and essential questions for that power standard. Each skill, in turn, will then have a corresponding subpage link at the bottom of the main page for the block. You will also address essential questions in those subpages as appropriate. The main page for each block will also detail the key math skills needed for the power standard, as well as the labs and activities supporting mastery of that power standard. The next portion of the page will explain how students will be evaluated for mastery of key skills. There will be a notebook check at the beginning of every block. Students must have 3 items in their notebook to get credit: a list of the homework problems required, handwritten definitions of key terms, and all equations that a student can locate in the designated chapter of the text. This is an all-or-nothing assignment to force the students to become familiar with material. Students must have all 3 elements by the assignment due date or receive a 0 for that assignment. There is no makeup credit available for this assignment. The other Block 2 evaluation guidance is as shown. The summative evaluation for a power standard is the word problem and multiple choice test combination. All other evaluations are considered formative. To put it in layman's terms, formative assessments are those that help us measure your progress as we learn the material. The summative evaluation is to determine whether or not you have actually acquired or gained mastery of the power standard for the block. Be aware, in the case of the summative assignment word problem test, any student that is not proficient on that test will be required to do remedial work until, in fact, they have mastered the concepts for that test. It is almost impossible to go forward in physics to new objectives when you have not yet mastered the previous objectives. Physics builds, especially in the kinematics subjects. Finally, each block page details the terms for that power standard and provides a link to the MIT OpenCourseware for exposure to how the same power standard might be addressed in a lecture on campus at MIT. Once familiar with the block requirements, the student may then begin by selecting in sequence the subpage links that address each essential skill needed to master the power standard. These links are at the bottom of the main block page. Each skill page will then direct the student through a sequence of activities. The student will finish a skill section by completing a formative assessment that could range from a practice set of problems to a lab or activity. The student will proceed to the next skill after demonstrating mastery of the skill in this section. When all formative skill assessments are completed in all of the key subsections or subpages, the student will then complete the two-part summative assessment consisting of a word problem test and a multiple choice test. Be aware, in the case of the summative assignment word problem test, any student that is not proficient on that test will be required to do remedial work until in fact they have mastered the concepts for that test. It is almost impossible to go forward in physics to new objectives when you have not yet mastered the previous objectives. Physics builds, especially in the kinematics subjects. One good thing about My Big Campus is access to supplementary materials. Students will have access via links from My Big Campus or My Big Campus videos to a wealth of materials such as those provided by the Khan Academy. Students are encouraged to use these if they are having any difficulty with any specific concept or skill. This helps address what we should do when a student has not yet mastered a topic or is experiencing some difficulty in the process. Some students should expect to complete remedial math skill activities until their Algebra 2 skills are sharp enough to do physics problem solving. Make a note, math, specifically algebra skills, have been historically weak for many new physics students. My Big Campus offers a number of opportunities. In this case, a master instructor or one experienced in this particular course material can build the My Big Campus course complete with lessons, support materials, and an evaluation plan. That instructor can also have input in terms of how the course should be paced. The instructor can also use the platform to mentor the in-class instructor and to assist where needed. The in-class instructor then would execute the lessons and evaluation plan plus provide academic assistance. This course will also serve as an example of the collaborative advantage we have with My Big Campus. My Big Campus serves as a repository, a starting point or template, and collaborative tool. The course will serve as an example or template for a way to offer an integrated part online, part classroom course. This model will be as dynamic and flexible as the person's authoring and maintaining it. It could also prove a model for collaboration, where you build the basic course for a common prep, then clone it for individual teachers to build upon.